welcome to our review on pressure and concentration and how they affect the rate of a chemical reaction. Now what we're going to do in this little presentation is to have a look at the two different factors that can affect that rate of which this reaction is going to take place. So first of all, we're going to have a look at pressure. Now the first thing to bear in mind here is that the reaction has to involve gases for the pressure to be a factor. If it's liquids or solids, we don't need to think about pressure at all. So any reaction that involves our gases, then pressure can affect its rate. Now the way that it does this then is as we increase the pressure, we see an increase in the rate of reaction. Now the reason behind that is as we increase the pressure, what we're actually doing is putting those same particles in a smaller volume. Now that means that those particles are more crowded, and that means that they're going to collide with each other more frequently. So just to illustrate that, what I've done at the bottom there is given you two little diagrams just to show you the difference between the low pressure on the left, where those particles are quite spaced out. So if you imagine as they're moving around, they're less likely to come into contact with each other. And then the high pressure on the right there, a much smaller volume because we're under much higher pressure, which means that those particles are much more crowded and therefore more likely to collide with one another. If we're talking about our liquids, then we need to think about concentration. So first thing we've got to understand is what concentration actually means. So when we're talking about the concentration of a solution, quite simply we're looking to see how much solute is dissolved in the solvent. So the solute is the solid that's going to do the dissolving, and the solvent is the liquid it will be dissolved into. So what we actually find then is that a high concentration of a solution is going to have a large amount of solute dissolved in it, whereas a low concentration only has a very small amount of solute dissolved in it. So the pattern we'll see with our concentration then is that as we increase the concentration, then the rate of reaction is also going to increase. Now the whole reason behind this is again down to those particles becoming more crowded. So if you imagine you've got a more concentrated solution, there's more of those particles in the same volume, which means they're going to collide with the other reactant far more frequently. And again, the phrase we've got to use in our exam, not just saying that they're going to collide, but saying that there are more frequent collisions.